So you got to understand about two-dimensional motion, and we have a object moving in one dimension. It would look something like this. So we have a straight line. If the object is over here, for example, maximum what can happen is it can go either this way, this way, this way, back and forth. That's it. So the object could not do anything else other than this. So this is your one-dimensional motion. Now we got to see two-dimensional motion, got introduced to the idea of two-dimensional motion. So we have a plane and the same object can go in this manner. And I can't show you guys three-dimensional motion. You can move your hand. That's your three-dimensional motion, right? So this is your two-dimensional motion. So in this two-dimensional motion, if I happen to make an object move in this manner, okay, something like this. If I make the object move in that manner, that would give us projectile motion. So this is just a fancy way of saying something is thrown up and goes up and down. So we are going to study about projectile motion. That's it. Okay, in this section, we're looking at something called as projectile motion. Projectile motion is nothing but your two-dimensional motion itself. Just that we are throwing something in day to day. If you guys sit over there, if you make a paper ball, right? If you throw it up straight, perfectly up straight, you will get one dimension motion. If you happen to move or throw, not move, throw it at a particular angle, you'll end up getting a path, and that path is your projectile motion. So you'll understand all about the projectile motion. It's the most common thing that we experience in two-dimensional motion, and so we're going to study about that, right? So we're going to start off with that. The funda does not change. The fundamental aspect of all of this motion being considered as motion along the x and y axis, that will not change. So example, this motion, I can consider it as a motion along the x and y axis in this way. Can you see that? I don't know if how clear is this. Okay, can you see that? You can see some dots over here. Oh, I don't think so. You'll be able to see that. Kind of, you're able to see that in with some degree. Okay, something. Can you see the red dots on the x and y axis? That is every second movement of the particle. So you can plot, you can take x and y axis, right, like this, or let me show it here. Actually, let me do it off. That will make more sense. If I happen to take x and y axis, and if I happen to do this, why is this happening? I'll tell you guys later. If I happen to do this, that is along the x-axis, I'm taking equally spaced points. If we happen to do this, right? And along the y-axis, if we happen to show this, just a second, I'll show you guys what I mean. So if we happen to show a velocity, some velocity, but deaccelerating at say some value. Let me actually increase this, make it as 80, I guess. Right? What have you seen in one-dimensional motion? So when you have an initial velocity of say 80, but your object is decelerating, what happens? The motion will look something like that. Is it not? So I can do a better job. Let me change its position to left of the origin. right? You get to see this, is it not? So same set of points, something like this, right? Keeps on reducing. I'll just mark it over here. So some big gap, then some reducing gap, and some more reduction, some more reduction, some more reduction, and so on and so forth. Okay, now if I happen to plot, let me take the graph. Actually, I should use the graph itself. So anyways, I've done this now. So if I happen to take the dots, let me change the color. So one is over here, the other is over here. Not exactly, I'm not doing a good job. One is over here, one is over here, and this is over here, and the next one is over here. And I follow the same thing at the other end also. So I should be doing this, or I can just do this. Right? And somewhere over here, the next dot is over here, and this is over here. Again, I'm just plotting, guys, nothing else. So can you see what's happening? What is that you're looking at? That's it. So what did I show over here? Can you see that? This and this. So this very graph, if you kind of paid attention, if I join all of this, that's how an object will move when you happen to throw it in air at a particular angle on the surface of the earth. So this is your projectile motion. So here, what is the thing that you have to make a note of about the distance? It's fixed, is it not? That's what I did over here. While over here, I happen to take the distance of a particle or an object. Let me write it over here. With u being greater than 0, while acceleration being a negative value. So basically this case was a deceleration. I took those points like we have seen in one dimension motion. So when I did that, when I plotted all of this, I got a projectile motion. So projectile motion is a combination of along the x-axis, it's fixed distance covering every second. So indirectly, v of x is constant, while v of y is a function of time, something of time. This is a constant value. It's not a function of time because it's not varying with time, right? While this is varying with time. If you understood this, we are done with projectile motion. Everything else is a bit of math. And yeah, the math is not that easy. It's a bit tough, but if not conceptually, this is it. Any object thrown into space with initial velocity, that is initial positive velocity, that is non-zero velocity, becomes a projectile. This projectile continues to move under the influence of gravity alone without any engine or any other means of propulsion. Terms to know: trajectory, it refers to the path that an object follows through space over time. So what I drew over here was trajectory of this particular case. The path that the object moves in. That's it. Right? Again, please understand that you can break down the projectile motion into other two-dimensional motion like any other two-dimensional motion. We are separating the horizontal component and vertical component. Horizontal component is not affected by gravity, while the vertical component is affected by gravity. And so we have it over here. And this acceleration is because of gravity. Gravity just pulls an object down, right? Gravity has no role in horizontal things. That's why when you keep anything on a table, it does not move because the gravity is not pulling it down. Is it not? If I keep anything on a table, the only thing that is acting on it is the gravity, right? Force of gravity. There's nothing pulling it to the right. Nothing is happening. No gravity. At least no Earth's gravity. Okay. So no Earth's gravity is acting on it. Okay, guys. So since there is no acceleration, so what is happening over here? Velocity remains the same. So that's what it's mentioned over here. It's the same point again and again. Nothing fancy. So same thing as a principle, using the principle of physics of independence of motion, we can understand that an object is in projectile motion has two independent components, one horizontal, another vertical. Horizontal moves with a constant velocity while the vertical gets affected by gravity. That is, we are considering that there is absence of air. So these are some of the assumptions that we make. No air. Effect due to curvature of Earth is neglected. Effect due to rotation of the Earth. All of this we'll understand in time. When you go to the chapter of gravity, there it will make more sense. For all points of the trajectory, the acceleration due to gravity is constant, both in magnitude and direction. So acceleration due to gravity, the value of g does not change is the point throughout the journey. So those are some of the assumptions. Okay. So we are still in two-dimensional motion. We are picking up a specific case of two-dimensional motion, and that is your projectile motion. That is, when you throw an object in air, it gets pulled down by gravity and it follows a particular path. And the main thing that you need to consider is within this slide board. So if you guys understand this, all of this component, whatever I've written, you are done with projectile motion. Okay, so see what you guys want to copy.